So something interesting that we can do is we can take our natural numbers, the set of numbers that starts with 1 and goes 2, 3, 4, 5, 6, 7, 8, 9, 10, and increases by 1 on and on. And we can form an entirely new set of numbers with them. And these numbers are called the rational numbers. You probably know them by the word fractions. And I know just saying that sends terror throughout you. So I'm just hoping that we can do a few things with our rational numbers and we can kind of lessen our fear of using them. So the set of rational numbers is given by, here's some set builder notation. Earlier in this class, we talked about sets and set builder notation. The first part of set builder notation is the blueprint for whatever's in the set. And so rational numbers are given by something in the top, a division bar, something in the bottom. Typical way of writing a fraction. And those fractions, the components, the things that we can use are A and B are integers, and the only constraint is that the bottom cannot be 0. For any rational number, the number in the top A is called the numerator, and B is called the denominator. So we're just going to review a couple things to do with our rational numbers. I'm not going to talk really too much in here about adding, subtracting, multiplying, and dividing. If you do not know, or you never learned, or you don't recollect how to add and subtract and multiply and divide, send me an email. I have other videos from different classes that can get you caught up to speed. What we're going to do first is we are just going to first talk about writing a fraction in its lowest terms. And what that means is I want to make sure that the number in the top and the number in the bottom don't have any factors in common. Now, the way we're going to do this is we're just going to use our rules for divisibility, and we are going to take out any common factors. So notice 130 and 455. They both end in a 5 or a 0, so that means the number 5 goes into both. So here's what I'm going to do. I'm going to take the number 130. I'm going to use my calculator. Okay, remember, you are fully able to use your calculator, and I'm going to say, okay, 130 is 5 times 26, and 455 is 5 times 91. And so the process of reducing our fraction is we now can divide. 5 divided by 5 is 1. We call that canceling, but canceling is just dividing out things that are in common. Now I have 26 over 91. 26 I know is 2 times 13. So my only choice for 91, at first you can look and see if it's on your list of prime numbers. I know 2 is not going to go into 91. It's not even. So let's see if 13 does. And it happens to. So 26 is 2 times 13. 91 is 7 times 13. And so I can cancel those 13s. 13 divided by 13 is 1. And so this fraction, written in lowest terms, is 2 over 7. I'd like you to please do the same thing for exercise 1 right below. Take 72 over 90 and write that in lowest terms, please. Okay, again, I hope you paused the video. Just sitting and watching this makes absolutely no sense as a use of your time if you are not actually performing the problems. So 72 over 90, well, I can see both of those numbers are even. 72 is 36 times 2. 90 is 45 times 2. So I can cancel those 2's. They divide out. 36 and 45, well, I know my multiplication tables, and so I know that 36 and 45, 9 goes into both of those. 36 is 4 times 9, and 45 is 5 times 9. And then 4 and 5 are both prime numbers, or sorry, no, they're not. 5 is a prime number. The only factors are 1 and 5. Neither 1 nor 5 go into the numerator of 4, so that is lowest terms. Now, something else we can do, and our calculators do this, and I know you can use your calculators. I'm just going to remind you where this comes from. When expressed as a decimal, rational numbers either terminate or they repeat. All a fraction bar is division. I know you're full well can use your calculator, but for these two problems, just humor me and we're going to do the division. 5/8. So I'm going to take 8, I'm going to divide it into 5. I'm going to put a decimal here. 8 goes into 50 6 times. I'm going to add another 0. 8 goes into 20 twice. I didn't leave myself enough room here. I apologize. 20 minus 16 is 4. Bring down another 0. And 5 times 8 is 40. This is a terminating decimal. 5/8 is equal to 0.625. That's the same thing your calculator would tell you. Okay, that's a terminating decimal, 625. So pause the video. I'd like you to divide this, but again, I know that I can't stop you from doing whatever you want to do. So I want you to write 3/16 as a decimal for me, please. Okay, so here's my division set up. 16 goes into 30 once, leaves 4, bring down another 0. 16 is going to, oh, excuse me, that was terrible subtraction. 30 minus 16, that's 14 and not just 4. I was getting all excited. 16 goes into 148 times. So 6 times 8 is 48 and 8 and 4 is 12. That leaves me a remainder of 12. Bring down another 0. And we do this process until we notice a pattern develop or until we end. So now 16 goes into 127 times. So 7 times 6 is 42, and that's 11, and that leaves me a remainder of 8. And then bring down one more 0. 16 goes into 85 times, and you got 3/16 is equal to 0.1875. Okay, so that's examples of terminating decimals. The next one, 7/11. So let me get my pen. I'm going to go ahead and do this. So I'm going to divide 11 into 7. 11 goes into 76 times. That's 66. Leaves me 4. Bring down a 0. 11 goes into 40 3 times. That's 7. And notice what happens. I've got a number here, 70. That is the same thing as I started with. And so what's going to happen when I bring down another 0 and I get 66, I get a remainder of 4. Well, we already had that remainder. And you can divide this out, but you notice what's going to happen is we're going to get 0.6363636363, and it's going to keep going forever like that. And so the way we write that now as a decimal is you take the part that repeats, 63, and we're going to write a bar over that part. So that bar means 63, 63, 63. Now be real careful with that bar. If you just write 0.63 and then put the bar over the 3, that is communicating something different. That is 0.6 and then 333333333. So that is not what we have here. So that would be wrong. So be very careful with your bar when you're writing this. So what I would like you to do, exercise 3, please write 5/6 as a repeating decimal. All right, we've unpaused the video. 6 is going to go into 5. 6 goes into 50. That's going to happen 8 times. 8 times 6 is 48. Now I have a remainder of 2, so I bring down the 0. 6 goes into 20 3 times. 6 times 3 is 18. Get a remainder of 2, bring down another 0. Notice I have no other numbers but 0 to bring down. I'm going to keep getting, every time 6 times 3 is going to be 18, I'm going to keep getting another remainder of 2. So 5/6 is going to be 0.0. Now what's repeating? Only the 3 is, not the 8. So when I do my bar, I'm going to be real careful just to put it over the 3. 0.8, 3333333. And there we go. All right, next thing on our little list of tasks to do with fractions is we're going to take the decimal 0.49 and we're going to write it as a fraction. Now, this, what you're going to do is you're just going to use the place name and try to make this as nice and quick and clean as possible. This is 0.49. That 9 is in the tenths, hundredths place. And so because of that, we're going to take the 0.49 and we're going to say it's 49 over, no more decimal because we're writing as a fraction. It's 49 over 100. That can't be reduced, so it is done. That is 0.49 written as a fraction. I want you to flip the page. I want you to pause the video, and I want you to do the same thing with exercise 4, please. Okay, so here we have 0.086. The 6 is in the tenths, hundredths, thousandths place. So instead of my decimal, I'm going to have 86 over, so no more decimal in that number, over 1,000. And now I'm going to take a little time to reduce it. So both of those numbers are even. So 86, when I divide 86 by 2, I get 43. When I divide 1,000 by 2, I get 500. The only numbers that go into 500 are 2 and 5. Okay, there's just a bunch of 2s, a bunch of 5s. Neither 2 nor 5 go into 43, so that is fully reduced. All right, we're just going to end our time reviewing some of the operations. Again, I'm not going to take great lengths to remind you of these things since you've been doing them since middle school. So if you struggle with the operations with fractions, please send me an email. I have some exercises that you can do to brush up your skills. So what we're going to do here is this order of operations problem. I've got 1/2 plus 1/3 divided by 1/5. Okay, so first thing in the parentheses, I'm going to do the 1/2 plus the 1/3. I'm going to come over here in my scratch work. Well, to add fractions to subtract fractions, remember you need a common denominator. To find a common denominator, you use your process for doing the least common multiple. But these numbers are nice and relaxing. The only factor of 2 is 2. The only factor of 3 is 3. So the least common multiple is going to be 2 times 3 or 6. The challenge is to now take that number that has a denominator of 6, and I'm going to change the numerator to make an equivalent fraction. So 2, what do I multiply 2 by to make 6? Well, I multiply 2 by 3 to make 6. So my numerator, 1 times 3 is 3. 3 parts out of 6 is the same thing as 1 part out of 2. Over here, what do I multiply 3 by to make 6? Well, I multiply that by 2. So you have to multiply the top by 2. 1 times 2 is 2 out of 6. And to add, now I just add those numerators. 3 plus 2 is 5 parts out of 6. So over here, my parentheses become 5 out of 6 divided by 1 over 5. To divide fractions, what you do is you multiply by the reciprocal of that second fraction. So 5 over 1. Okay, hopefully that looks familiar. And multiplying is the least stressful property to do with fractions because you just multiply the tops, you multiply the bottoms. So we got 5 times 5 is 25, 6 times 1 is 6, and there you go. The answer to that problem is 25 over 6. So I'd like you to please pause the video, and I would like you to look at the next problem, exercise 6. Use the order of operations to simplify that. Pause the video. I'll be back in a moment. All right, I'm back. So here's what we're going to do. Order of operations, I'm going from left to right. I've got some multiplication to do. I'm going to do this on my scratch work over here. So I'm going to go 9 over 4 times 1 over 3. And that is 9 on the top. And 4 times 3 is 12. But I can reduce that. They both have a factor of 3. So 9 divided by 3 is equal to 3. 12 divided by 3 is equal to 4. So that reduces to 3 over 4 plus. Then I've got 3 over 4 divided by 5, 6. So that's going to be times 6 over 5. And so 3 times 6 is 18. 4 times 5 is 20. Both of those numbers are even, so I'll divide both by 2 to reduce it. 18 divided by 2 is 9. 20 divided by 2 is 10. It doesn't reduce anymore. Now I've got to add these two numbers, so I need a common denominator. Again, use your strategy of the least common multiple. Okay, and the least common multiple of both of these, of 4 and 10, is going to be the number 20. 4 times what is 20? Well, 4 times 5. So 3 times 5 is 20. Excuse me, no, it's not. 3 times 5 is 15. That's a 15 right there, sorry. 10 times 2 is 20. So in the top, 9 times 2 is 18. And what we get right here is 15 plus 18 is 33 out of 20. That's what we get when we simplify that. Now, there's one more thing to do in this section, and then we're done with our quick talk about rational numbers. The rational numbers are interesting because unlike the natural numbers and unlike the integers, the rational numbers are what's called dense. And what that means is that if you have any two rational numbers, R and T, then there is always another rational number between them. Okay, so density means between any two rational numbers, okay, so between R and T, there's always, every time, no matter what, going to be another rational number. And so we're just going to talk about finding one of those. And the quickest, easiest, cleanest way to do that is what we're going to do. This is my example, then you're going to do the same thing. We're going to find a rational number halfway between 1/2 and 4/5. Well, all you're going to do for this is you're going to first add them up. And then the second thing you're going to do is you're going to divide by 2. So let's add up. So first thing we're going to do is we're going to add. So we're going to take 1/2 plus 4/5. Common denominator here is 10. 2 times 5 is 10. So in the top, 1 times 5 is 5. 5 times 2 is 10. So in the top, 4 times 2 is 8. And 5/10 plus 8/10 is 13/10. Then what you're going to do, secondly, is you're going to divide by 2. Well, dividing by 2 is the same thing as multiplying by the reciprocal, so we can multiply by 1/2. Either way. So we're going to take that 13/10 and we're going to multiply by 1/2. And so 13 times 1 is 13. 10 times 2 is 20. And so 13/20 is halfway between 1/2 and 4/5. Now, I know that's not quite super obvious, so let's just verify this with our good buddy, the calculator. So let's use decimals. We're probably more fond of decimals. So 1/2 is equal to 0.5. 4/5 is equal to 0.8. Well, let's see. Where's 13 out of 20? 13 divided by 20. 13 out of 20 is 0.65, and 0.65 is halfway between 0.5 and 0.8. That's the number we want. You add them up first, then you divide by 2. So I would like you to finish off by pushing pause and doing exercise 7. Find a rational number halfway between 2/3 and 7/8. All right, here we are. Last problem for this one. So first thing we're going to do is we're going to add these two numbers together. So I've got 2/3 plus 7/8. Common denominator between these two things, a least common multiple between these two is 24. 3 times 8 is 24. So the numerator, 2 times 8 is 16 out of 24. 2 parts out of 3 is the same thing as 16 parts out of 24. Over here, 8 times 3 is 24. So 7 times 3 is 21 out of 24. And when I add those together, I get 16 plus 21, or 37 out of 24. Then I divide by 2. Divide by 2 is the same thing as multiplying by 1/2. That's the reciprocal. So 37/24 times 1/2. 37 times 1 is 37. 24 times 2 is 48. I'll leave that to you to verify with your calculator that 37 out of 48 is halfway between those two numbers. But you have just shown that between any two rational numbers, we could find another one.